All right, thank you. So we'll go ahead and get started here. So this is my depiction of a Kubernetes operator. Now, you might be asking why he's frowning, and I have the answer for you. So he's got 3 Kubernetes clusters running in different places. Then we can imagine that these are different clouds, and one of them is an OpenShift cluster because some of his devs want OpenShift. He's got Rancher with Kubernetes, and he's got this like weird skunkworks team that went off and did their own Kube8am cluster, and then he ended up having to manage all of these different clusters, right? So the problem is that as he's getting towards his deployments and trying to strategize on the way that he's going to perform application deployments across these clouds, he doesn't really have that connectivity between his clusters. Pods can't talk to pods unless you find different ways of transversing that traffic, using something like an external IP or load balancer or something. That's just not fun. So that's what Submariner is really here to do. It's a multi-cluster Kubernetes network connectivity tool. And so because of that, it makes our Kubernetes operator happy. And this is, I know it's a pretty bad graphical depiction of what this does, but we can actually talk about, using text here, what Submariner does. So Submariner really is going to allow your pods to directly communicate between your Kubernetes clusters. It's secure, so it's actually using the current implementation today uses IPsec tunnels, so it actually will establish IPsec tunnels between your Kubernetes clusters. It's also CN agnostic, so that it's actually operating at a layer independent of most network providers. So whether you're using something like Flannel or OVN Kubernetes, you actually can have your pods talk to each other. And what we'll be demoing today is actually an OpenShift cluster talking to a Kubernetes or a Rancher Kubernetes cluster using Flannel or Flannel on our end, and then OpenShift is using I think it's
OpenShift as the end.
Yeah, so it's pretty neat stuff. Now, how does it work? I get this question a lot because the idea of trying to connect these overlay networks together, there's a lot of different sort of architectures you could come up with, but this is the simplest one we have. So essentially, we have a central component which we can consider our Submariner broker. In the current implementation today, it's actually a Kubernetes cluster that is using CRDs, and we have each cluster that's going to be connected to each other, interacting with that broker cluster and exchanging information, or really it is metadata between the data path itself is going to be using IPsec. In each cluster, you actually have one or many gateway nodes, and Submariner does leader election to determine which gateway node is active, and will actually establish the IPsec tunnels between the gateway nodes, which is why that graphic there kind of shows the overlap there. And with all of the other worker nodes, master etcd, and so forth, if they're running the Submariner route agent, will actually have VXLAN devices configured on them independent of what you would have for Flannel. But that's actually how within the cluster we send traffic, for the remote, remote clusters when you're trying to cross communicate. So a little bit of history here. So the history of Submariner was first conceptualized in 2017. When I was sort of running OpenShift and had a lot of questions come up around how do I get clusters on one side of the country to talk to clusters on the other side of the country, and there was no good answer at the time. I mean, you could do things like layer 4 load balancers, or you could try to figure out how to tunnel your traffic through ingress or your routes or whatever. There was no good solution for this. So I kind of had this dumb idea of trying to connect these clusters using IPsec tunnels. And so the first prototypes were written in actually late 2018 when I was basically writing bash scripts, dropping them into containers, and then letting Strong Swan establish IPsec tunnels between them. And then it was pretty bad. It had host routing and stuff like that. It was it required layer 2 adjacency. So I actually ended up taking all that sort of those bash scripts and turning it into a sort of more of a controller model with Kubernetes. I built it around using Go, and when I actually released the first version of Submariner in March of 2019. And then after that, it gained a lot of traction to get to where it is today. And so we've actually been collaborating as a community on Submariner since to try to help enhance its reliability as well as usability. Because like I just said, one of the big things that we had problems with was the fact that we needed to have layer 2 adjacency for the nodes, and that was just, I mean, how could you do cross AZ if we're within the same, it just didn't work. So we ended up, basically integrating VXLANs, and now your nodes are able to live in other places and still actually send traffic to remote destined clusters. And the other big thing I kind of wanted to call out here is, Submariner is a community project, right? So we're trying to get, feedback from people who want to, who have use cases or who want to be, using Submariner for, like basically if you have a use case for it, we'd love to hear about that, and we'd love to sort of, if you want to sit down and look at the code base and try to help us out, like, I mean, we're definitely welcoming that. So we did make a new release, so Submariner 003, which has that VXLAN enhancement and still does the IPsec, IPsec for tunneling, was actually released yesterday, and that's, we basically were like, oh, we're at KubeCon, we might as well release it. So we definitely would encourage you to check it out after this.
Okay, and then, I wanted to talk a little bit about the change log from the first release that Chris made, and the changes that we have been introducing in the community since we joined from Red Hat. On the 001, we had NAT at some point in the data path. So when the packets arrived the destination cluster, the IP address of the originating pod was lost. So we fixed that with the encapsulation in the clusters, inside the clusters. And then we extended testing as much as we can. We are still doing that. So the testing that we do is really, we test all the possible cases that we can think of connectivity, and we are working now on more complex things like adding clusters, removing clusters, trying to break up things. There are my colleagues who are working on that stuff. We also added a lot of unit testing. We still have more to do, so if you want to join the community and help us out, that would be great. And also, we have been working on an operator to maintain your Submariner deployment in your cluster, make sure that it's healthy, that you can upgrade it, that you can deploy it really, really quick. We are going to show you on the demo, and it's amazing. And with the operator, it comes a tool what we have called subctl, and we'll just show you. So on the roadmap, we have support for overlapping IP CIDRs. It's a pretty common case that people want to connect already existing clusters, and it's very likely that you will have conflicting IP address ranges. So we are coming up with a solution for that. We are also working on service discovery across clusters, network policy support, because it's more complicated across clusters. Supporting other network plugins, like currently, I think at least it runs with OpenShift, SDN, Flannel, WIFnet,
It should work Calico, IP and IP. So
most of them, if they are based on kube proxies, very likely that they will work. But if not, we need to do some level of integration that we will be doing. We also want to add status monitoring and improve subctl further. I will show you later.
Yeah, so as Miguel sort of alluded to earlier, one of the biggest problems we run into with Submariner is regarding overlapping CIDRs. So if you have two Kubernetes clusters, and I'm just going to, because I'm most familiar with this, let's say I'm spinning up my Kubernetes clusters and I have my pod IPs on 1042.0.0/16. The problem is if I try to dial, from cluster A to cluster B, I don't have a really good way of, or actually you basically conflicting routes because how do you know what cluster you're in? So overlapping CIDRs is definitely a problem. And currently the proposal right now is actually use sort of a global overlay CIDR where we'll do a little bit of translation and sort of have a one-to-one relationship between the pods on cluster, within what would be cluster A and pods in cluster B. But that is obviously still in proposal at this point. So if you have any feedback or have any ideas on how to like do, sort of global clusters with overlapping CIDRs, we definitely, come check out the proposal we have in the Git repository.
Okay. And on the roadmap, we had the service discovery. And so for that, we created a sub-project because we want to keep the concerns as separate as we can. And that project is Lighthouse. So the idea with Lighthouse is that you can resolve DNS, or we are also looking for other methods. But so your application doesn't really need to know where your service is running. Hopefully, at some point, we can make it like select first local services. If the service is running on both and several clusters, say, okay, I prefer to go to the local cluster first, and if that is not available, then go to the remote clusters. And so there are there is new APIs on Kubernetes that will let us define that kind of behavior. And this is how it looks currently for the design. We are creating a core DNS plugin and a controller that will discover like the remote services and create local CRDs that this core DNS plugin can reply with. So a pod that runs in this cluster will make like the DNS query and discover this remote service living on the other cluster. And the other very important topic that we need to look at is network policies. If you are connecting your clusters, it's really important that you take care of security, and network policies are for that. The problem with network policies is that the network plugin in one cluster does not know about the pods in the remote cluster. So it needs to, we need to put some mechanism in place to let the local network plugin of that cluster to know about the remote pod IPs. So this is the normal case. Coast Guard, just local traffic, and network policies select pods based on labels, namespaces, and this network policy for this pod is selecting pods with this label. In this case, it works. It's able to connect. So if we have a remote pod, the IP will not be known by the network plugin, so the traffic will be blocked. What we do with Coast Guard is, I'm simplifying this, but we discover the remote pods, and we create, this is a proof of concept. It works, but we create like additional network policies parallel to existing ones with the remote pod IPs that match the network policy. Eventually, that can change. This is only a proposal and something to start with. And deployment options. Currently, you have several. You can use Helm, which is what Chris created initially. You can use the new Submariner operator. It's like a first release that does basic deployment. And you can use subctl that I will show how it looks, because it's a little bit complicated to otherwise to deploy, and we wanted to make it very easy. So we went from a, 8 pages document explaining how to deploy Submariner to 2 lines. And very happy about that. So using subctl, this is how it looks. You can choose your broker cluster. You need the admin context for that. And you say, OK, deploy broker, and that's going to deploy the broker for you. And it will ask for anything that it cannot figure out. and it will produce this broker info Submariner file. And then you go to the next cluster, and you say, OK, join and my kubeconfig. This is my cluster ID, and it will make sure that it's installed and connected. And I will show you how it works. Hopefully, it will work. We depend a little bit on the Wi-Fi, which is a little bit on the edge. But OK, yeah, I wanted to. So what we are going to demo is what we had at the start. It's vanilla Kubernetes cluster, rancher cluster. So this one is running Flannel. The rancher cluster is running Flannel with Canal, and the OpenShift cluster inside the Red Hat network is running OpenShift SDN. So they are different plugins and technologies. Let's go to the demo. Before I go into the demo, I wanted to say thanks to all my colleagues at Red Hat, which supported me to make sure that this was possible with deployment of clusters, last time bug fixes and stuff like that. Thank you, Sridhar. OK, so the first thing that we do is go into the rancher cluster, and we will do the deploy broker. Yes, sure. Does it work better? OK. OK, it's going to ask for the name of the cluster. We need an ID. And OK, now it's deploying the broker and the operator. It tries to figure out the cluster IPs, like the range for the cluster IPs and the pod siders. Sometimes it's not possible because it's not straightforward.
Yeah. Implementations of Kubernetes tend to be different. So for example, in the newer versions of OpenShift, you have static pod manifests that you can scrape to figure out what your siders are. But in the rancher world, we don't do static pods, so that's why we don't know what the service sider is.
Yeah. So OK, now Submariner is running on the rancher cluster, and we have this broker info file, which is basically JSON encapsulated in base 64 to make sure that people don't break it. You can break it anyway. So if we look at the pods in the rancher cluster, they are running. This is the Submariner engine on the gateway, and those are the route agents that run on every worker node, including the gateway. And this is how the broker looks like. We only have one cluster that connected 1 minute ago. And yeah, we can look at how a cluster looks. It has the cider, the cluster ID, the color codes, that it's something to this simple way of making sure deciding how clusters connect to each other. So the blue ones will connect to the blue ones, the red ones to the red ones. But there are ideas to enhance that. So now what I'm going to do, sorry, I need to make the font a little bit smaller. I'm going to connect the cluster in Red Hat to the rancher broker. So this is, please note, I'm connected to the Red Hat VPN because that cluster doesn't have any public IP at all. So every connection that it does to the internet is via NAT. There is no IP address pointing to that cluster. So we will be doing IPsec NAT traversal to make that work. And this is the vanilla Kubernetes cluster. In this case, we didn't mark any node as gateway, so the installer is going to ask which one shall we pick. We can pick this one. OK, so at this point, we can look at the pods. We're having a weird DNS issue on the Red Hat cluster, so maybe it's working this time. Great. Otherwise, if it didn't work with the DNS, the Kubernetes magic will make sure that it works eventually. And we can look at the pods, at the vanilla Kubernetes cluster, and if we look now at the list of clusters in the broker, we have 3. Okay.
And so one thing I do want to point out, so if you remember earlier, I mentioned the fact that the broker is a Kubernetes cluster that is where we facilitate the exchange of that metadata for things like endpoints and clusters. So if you're actually looking at our demo here, you'll see that for the OpenShift cluster as well as the AWS kind of kubeadm cluster, we are specifying the kube configs for those specifically. But with the kubectl get clusters, that's actually living in that first I guess Rancher Kubernetes cluster that we spun up. So not only is that cluster I guess a component in our sort of mesh of multi-cluster multiple clusters here, but it's also actually storing the metadata for the rest of the clusters as well. So, yeah.
Okay, so now what I'm doing is making sure that we have like a couple of services that we can play around with, like Nginx and Netshoot, to be able to log in and play with the network in all the clusters. Now on the Rancher cluster, I'm going to run I have a grapper. We want to add that to subctl. Now it's still not doing it, but we can see that we have 2 tunnels established to the other clusters. Okay, and yeah, I will make sure that we have Nginx and Netshoot. Get a list of IPs. Maybe I need to make the font. No, font is kind of okay. Can you still see it? Okay. So with this, I will log in into the Rancher cluster. And so I'm running in a pod inside the Rancher cluster. And what I'm going to do is start by something simple, like a ping, to maybe this one. So ping works. We can also, for example, try a connection to the one in Red Hat with, I don't know, something silly like Apache Benchmark. Oops, the final. And it works pretty well. I mean, we only have the latency of the public network. I mean, yeah. And now we can do it from other places. If we connect to the Red Hat cluster, from there we can, for example, try to get a response from the Nginx on Rancher, and that will work. It's very boring because it's working all the time. It's yeah, and I can repeat the same from the other one, but I think it works. We're very happy. Okay, so if you want to try out subctl, you can get it from here. We just made the release minutes away. I'm sorry because we only have the Linux binary version, but we probably in the next week we will be adding like cross compilation, so you can have the binary for OS X or other platforms.
Yeah. So as I sort of mentioned earlier, if you're interested in Submariner as an operator, definitely join our mailing list and ping us, because we're trying to do our best to make sure that Submariner ends up being something that is usable, right? So that's very important to us. And additionally, if you're interested in contributing, we do run a weekly meeting on Tuesdays at 8 a.m. Pacific, or I think it's 5 p.m. Where Miguel's based out of, which is Madrid. And if you join that mailing list, you'll get an invite sent to you as well. And our repositories are going to be at github.com/submariner-io. Thank you. It is time for questions now.
I would also like to point out, if you if your company is working in a network plugin and you want to make sure that we are compatible also with your network plugin, please join our community. We are really open to making sure that we are compatible. Or if you are a cloud provider and you want to make sure that Submariner works in your cloud, please join us.
We have time for questions.
Yep.
Hold on, let me get this one here.
Hello. Yeah. So, thanks for creating this wonderful project, which is Submariner. So my question is regarding the. So, do we need a third cluster for acting as a broker? Is this a must necessity? So this is the first question I have.
Yeah, so you don't need a third cluster for your broker. If you're so in kind of a conventional use case has been two clusters that you want to connect together, and you can sort of, if you have a public API server for one of those two clusters, you can designate that. Or if you have the ability for the two clusters to sort of dial each other's Kubernetes API servers, or maybe one way or the other, you can actually get away with just two clusters in the architecture.
Yeah, if you see with the subctl, we made it the default that you only need two clusters to try it out. So unless you specify the no data plane flag, it's going to deploy in the deploy broker. It will deploy both the broker and the Submariner data plane. So you just need two clusters. But the one running the broker needs to be publicly accessible because all the clusters need to connect and exchange information there.
Okay, so this is based on establishing a IPsec tunnel between the two clusters, if I'm not wrong, right?
No, so the broker cluster is used to exchange metadata information regarding the endpoints of the clusters, and that's why that broker has to be accessible.
So the endpoints have information about what is every cluster IP address to make the IPsec connection, and what are the IP ranges of that cluster. So it's just to exchange information about how to connect to each other. But it's, if you try it out, it will be more evident. Yeah.
Okay, all right, thank you.
So we haven't done specific benchmarks yet. That's on our sort of list of things to do. Reason being that you're going to be limited mostly by crypto because of, well, it's IPsec, and then on top of that, it's wherever you're running your clusters. So we're looking at trying to give generic information regarding benchmarking, but we haven't done any formal tests yet to be able to give you that. But you can essentially expect your throughput to be what you would conventionally receive with just a standard IPsec tunnel between two nodes running out in your cloud or over the internet.
Yeah, I think that the biggest factor is probably the latency between your clusters. The closer they are, and well, you can always increase the window size. But yeah, but we really, one of the things that we want to do, as Chris said, is running like some
benchmarking.
Yeah, some benchmarking in different situations so people can have figures and maybe compare like, okay, what's the difference between going through Submariner and the IPsec tunnel and mapping the service publicly on the internet and connecting to the service. So I think that will be like a significant number that you can, use.
You said earlier that you were interested in use cases that that people had. So a use case I'm interested in is I have an on-prem cluster, and then I get a bunch of new pods that I want to schedule, and rather than queuing them up, I launch new clusters on cloud providers, burst onto them, but like put the workloads there, and then shut down those public cloud clusters after the workloads have completed.
Okay. Yeah, and those types of burst workloads are actually one of the use cases we are aware of, and we're actually working a little bit on with sort of SIG multi-cluster or actually SIG network and SIG multi-cluster to try what we've sort of talked about, and this is in very early stages. Being able to reference a local service in your cluster and have it aware or have essentially populated endpoints for your remote pods, and then running controller and exchanging metadata so that your application won't actually have to be modified past the fact that it's just going to be hitting that local service IP within your on-premise cluster, and that should actually, with Submariner connecting your clusters together, allow you to burst traffic into your burst clusters in the cloud.
We could take one more. Miguel?
This is just a follow on. What were the two SIGs that you were working with?
We're working. So right now we're in conversation with SIG network as well as SIG multi-cluster. Mm-hmm.
We have one more.
You're using IPsec now and everything. I was just curious, when WireGuard makes its way into the mainline kernel, is that just another approach that you guys will consider taking, or perhaps making it modular and plug in?
Yeah, so it is. So technically, when it was first when it was first written, it was built to be sort of modular. Like, I mean, it is modular, yeah. Right? It's just a matter of the actual implementation to make WireGuard work. I know WireGuard's come up before in the issues for the project. It's just we haven't. We're still focusing on other aspects of making it usable before we go focusing on other engines.
But we are going to be accepting contributions. So if anybody wants to contribute a cable engine for WireGuard, we're completely open. We're also looking into implementing other cable engines. For example, for VXLAN, I know VXLAN is not secure for your traffic, but it is useful if there is already a VPN between your clusters and you want to have that kind of connectivity, and you don't want the IPsec overhead.
Yeah.
All right. Thank you very much. We appreciate that. Please rate this last talk. Give it a happy face. That was a great talk.